Good morning, everybody. As Tammy said, I'm Sam. We're going to talk about Git. Now, for those of you who haven't read the prerequisites, then I suggest you do so now. There aren't really very many at all. You should have Git installed. I'm sure you all use Git quite a lot. So if you haven't got that, then good luck, because I don't know how you're going to get that this quickly. There's something called GitUp, which is part of the conference materials that went round. If you've not got that, then I suggest you install that. Again, really, really simple to do, really quick. Now, and also to pitch the level of this, because I don't want you to be here. Well, you can be here, but it's probably not very worthwhile if A, you've never heard of Git and you don't know what it is and you've never used it. So if you haven't done that, then I'm really sorry. This might go a little bit over the top of your head. And also, if you are an expert at Git and you understand everything, then it also might go over your head. So I'm going for the middle ground. You kind of know how to use Git. You use it day in, day out. You know how to commit. You know how to push. You know how to merge. But you're not really aware of everything else that's available. That's what we're heading for in this middle ground. OK. Oh, it doesn't work. Oh, there we go. Right. So I'm going to do 3 little bits at the beginning that are setting some scenes. They're slightly gear change shifts as well. We're going to start out with what is version control. Now, we all know this in some sense, but I want to kind of frame it as version control is the ability to kind of save a state of something that you're doing and then move on to a new state, and you keep that history of state. Now, we all associate it with things like Git and with SVN and CVS and Mercurial, but actually this is really simple, right? This is the same for like in an undo stack inside Word or something. That is version control. So you start doing some work, you make some changes, and that saves another state. And then you do a bit more work, and that saves another state. This here is just an undo stack. And then I do a bit more work and save another state. Now, say if I've got that Word document and I've written these things in, and I send that to somebody else. They then have that undo stack, and they start doing their work. This point here is a kind of branch off. This would branching off into something else. And then as they continue doing their work, they build their own undo stack. We continue our work. That gives us our undo stack. Now, the thing that makes version control as we know it, in terms of Git, in terms of Mercurial, in terms of SVN, in terms of CVS, all of the things that we kind of associate as software engineers, is the ability to take these 2 branches and merge them back into one thing at the end. You can't do that with undo stacks inside Word documents. That's the thing that we really care about, and that's the powerful aspect. Now, switching gears a little bit, I want to talk about Git as a file system. We're going to touch on this in this theory section here, and we're not really going to use it much later on during the talk. But I think it's a really useful way to get an idea of what exactly is going on inside Git. So we've got a little thing looking exactly the same. We've got a state, and then we've got a new state that we've got some more work from. Now, that state is actually represented by like a tree of things that exist inside my file system. I've got 4 files in there. The green ones mean they haven't changed since the last commit, and the orange ones have changed since the last commit. So how does Git actually store that stuff? How is that information stored as a Git commit? So we're going to go through a little story of that. Now, the way it works is this concept of a kind of blob store, and we're thinking of a key value store. So key value, literally, I have a key, and then I stick a load of guff in the value. So it's just a dictionary. That's all Git does. So what it can do here, it looks a little bit like this over on this side. The keys are all SHA-1 hashes, and they're organized in this kind of directory structure that uses the first 2 characters. This all sits inside that .git directory. There's an object subdirectory in there. This is what goes on in there. It all looks like this. So how does this storage actually go? Each of these files is represented in that blob store. You take each of the files, you find the key based on the SHA-1 hash of the contents of that file, and then the value, which is the value, the contents of the file inside the blob store, is just a compressed version of that file. So each of these have a one-to-one relationship with what is actually inside the blob store. So that gives you this arrangement of files. Each of those files, we've now stored them in this blob store. That's not really what we need, though. We also need to store those 4 files at this point in time look like this. And we do that with a tree object. Tree object is just going to be a file that lists these are the SHA-1 hashes of the 4 files in this checked out tree at this time. So you take that, and we can store that. That's a file. We can store that in the blob store as well. And we do that by SHA-1 hashing it. That gives us our key, the name of the file. And then we put the contents, the compressed version of that tree file, inside as the value in the key value store. So now I've got this ability that if I go to CBD5F, then I can find out what does this tree look like at this given point in time. That's still not quite what we need to know. We also need to turn this into a commit itself, which is where the next level up, so we've done the files themselves, we've done the arrangements of files together, and then the next level up is the commit that goes with them. And the commit here is another text file. It tells you, well, which tree do we need at this point, and what's the parent commit? So we put those two things in a file, and then we do the same again, SHA-1 hash it to get the name of the file that goes in, and we compress the contents to go in the value. And now we've finally got those SHA-1 hashes that you're used to seeing with Git commits, right? Each one is a SHA-1 hash, and that represents something in the blob store, which when you've got it, you check it out, you find out what the tree is, you then check out each of the files in that tree, and then you've got your commit. It all fits in this really simple structure. It's just a file system. And in fact, you can use Git as a file system. So we're not going to do any of that. I'm just telling you that. It's a bit of background. Showing off because I put the effort in to find out what it was, so I'm going to show off. Switching gears completely again, let's talk about what we're actually going to do today. We have got a Git repo that my 4 friends have been working on, I know. I do have 4 friends. Admittedly, they are imaginary. I've made all of these 4 friends up. But they've been working on a problem. They've written some code. They've written a Swift script to do something. They've all been working on it separately. And what we're going to do is stuff that we kind of have to do every day, turn that back into having the final, merged everything to master, all done. I've got the final script that we need. And what that code does is it creates magic squares. Now, I quite like maths, and it's maths with an S. So I've chosen something just because I want to write it. So a magic square is just a square matrix with integers in, the integers between 1 and n squared, where n is the order of the square matrix. You just put them all in there. And the thing that makes it a magic square is the fact that each of the rows and each of the columns and the leading and trailing diagonals all add up to the same value. Now, you don't need to know any of this. This is just a bit of background for the code that we're going to see. The code is pretty much irrelevant throughout all of this. We're learning how to join it all back together. The reason we chose this algorithm, I chose this algorithm, is because it's really easy for 4 people to work on it because it has 4 different separable components. So, moving on to demo 1. Demo 1 is we're going to do some work on visualizing Git repos, so a little tour around Git log and such like. We're going to look at merging, so the very simple cases of merging, and I expect that most of you guys are used to that kind of thing, but I think it's a good place to start. And then finally looking at some of the stuff you can do with Git ignore and the problems that are associated with it. So, jumping up, and what you need to do, if you haven't already, is find the starter inside the demo 1 project. That is a zip file. If you unzip that, that gives you a directory which is a Git repo. So I've got it here on my desktop. It's called Magic Square. Here it is, Magic Square. And then you're going to need a terminal, which I'm going to chuck in its own thingy. There, that's easy to read, isn't it? Let's make that a little bit bigger. How's that? Oh, it's still quite small. Let's keep going. There, is that all right? Can you read that? I'll take that as a yes. So I'm just going to jump into that directory, which for me it's on my desktop, so it's inside Magic Square. And because of the way that I've got my prompt set up, it tells me that I'm in a Git repo and it tells me I'm on the master branch. But that doesn't necessarily tell us very much about it. I've been given this repo and I want to know a little bit about its history, what's going on in there, who's doing what, and all that kind of stuff. And we're going to start by taking a look at some of the things you can do to visualize that. The first one is just git log. So if you just type git log, then you get to see something that looks like this. And this will be by default presented in something like more or less, so you can scroll up and down it. Each of these represents a commit. So you've got the orange line there is the SHA-1 hash that I explained where it comes from and what it does. Then you can see the author. You can see the date that it was, the commit happened. And then you can see the commit log that went in there as well. So that gives you some kind of idea, and you can see that from the master backwards. You can kind of get an idea of what's going on there. But it doesn't tell you everything. Now, to get out of less or more, I can't remember which one's being used, just press Q, and that'll take you back to the command line. Now, if I only want to see the four most recent ones, I can type git log -4, and then it's quite difficult to see on here because it's so big, but there are now only 4 things in there as opposed to the entire history. Now, something I think that is quite useful is to show, and I'm not going to go through, there are loads and loads of different things you can put on here, and if you look through the PDF, the book, then I think it starts on about page 110. There's a bit more detail about each of these, but I'm going to jump straight to what I think is quite a useful one. And if I do git log --one line --decorate graph, then it'll look like this, which I think is a bit easier to understand. Well, it would be if it all fitted on the screen. That's not very good, is it? What are we missing down this? Right. Just a sec, it's chopping it off, so I'm going to take it out of there. Like that. And then, I'm sorry guys, just give me a sec. Let's change this to default colors. Let's turn that off. Do that. There, that's better. Right. Is that okay? So we can see the edge a little bit better now, or some of the edges. Right, what this has done then, so one line takes each commit and turns it into a single line. Then what else have we got going on? Oh, the decorate, so we've got where it says here WCMD line and master and head up there. That gives you the branch tips that you're talking about. And then the graph bit gives you the kind of lines down the side of the page that give you some kind of ASCII representation of the Git history as a graph. Now that's quite useful, but you can't type git log --one line --decorate --graph each time you want to see that. So there's a little useful feature of Git called aliasing, and those of you who are used to writing stuff in shell, it's kind of the same as doing shell aliases, but it's specific to Git. So what can we do for that? So if you type in here git config alias.gl, and then what do you call that? Like a single quote thing, not a backtick, not a double quote, single quote. Type in there log --one line --graph --decorate. Does that make sense? So what we've done there is put in, this is the exact line that we ran before, but I've now put it with this alias. Now something that's important here is that this is all to do with git config, and git config is local to the current repo by default. But what you can do is put in there, instead of config, if you do config --global, then that will be on all of your Git repos in on your computer. But this one here, so now I've got that in, I'm going to run it. And what that's done is if I can now type git gl, then that has aliased that big old long thing, log --one line --decorate --graph, is now aliased as git gl, which makes life a lot easier. So now I can use this to see what's going on. Now, where did that put that? So you don't have to do this, but I just want to show you what that's actually done. If you do ls.git, so this is the hidden directory, and inside config, I can't type. Oh, not ls, you knob. Cat, there we go. So what we've got, what that did is it put this tiny little thing down at the bottom here. You see that at the bottom? I can't move it. It's down here. It's got this alias thing. There's some other bits and pieces in there as well. But that saved that into that git config. Okay. Next up, what we found there is I've looked at the high level of commits. What's in the commit? What's the relationship between the commits? So the commit message and such like. But what about the actual content of the commit? And you can get at that by looking at diffs. And the way that you would look at diffs, if you do git log, let me clear this first so you can see it. So you do git log -p, that gives you the commit by commit diff, which looks a little bit like this. So you can see at the top, again, we've got the commit hash, we've got the author, we've got the date, and then we've got things like the commit message. But new down here is the ability to see the diff itself. That shows you what actually happened between this commit and the current commit, the old commit. So how do you read those? Let's see if this laser works. Laser. Can't really see it. I'll just point. So what you've got in the diff here tells you where the diff's starting. And then it's tells you what are the two things that you're diffing. You're diffing from one commit to another commit. It tells you these two things here, which don't really mean anything in Git when you're looking at a Git diff, or certainly not a Git diff in this sense. The important part starts here on the double @ line, which tells you that on the old file, it starts at line 9 and it's 6 lines not long. And in the new file, i.e. the next commit, the current commit, we should also start at line 9, but now there are 16 lines long. Just put this light back. There we go. Professional to the end. Then what you can see then is that you have lines in the diff itself that show you some lines have been removed and some lines have been added. So if it's got a plus at the beginning, which in this case is green as well, that's showing this line has been added between the old commit and the new commit. And if I go further down to find a different diff between different commits, you can see that if it has a minus at the beginning, then that means that it's been taken out of the current commit and into the new commit. So that's roughly how to read a diff. These chunks, by the way, these chunks that started with the double ats, you can have more than one of those in each diff. It chooses these little chunks. Okay, couple more useful kind of logging things. The first up is the short log. So if I type git short log, and let's do wcmd line, let's show two things at once, ... head. So something that looks like that. So we're using the short log command, and we've got the name of the branch that we want to go from, which is wcmd line in this sense, and then the ... tells you head. That gives you the range of the ref that you actually want to run through. And if I do that, that shows me this kind of approach, which says it organizes, indexes by author, the commits. So it tells me that Xanthi did 2 commits, she did 2 things there, and Yasmin did 2 commits as well. That's really useful if you're doing like release notes or something, or you want to see who's actually done what. It's quite handy for that. So that's the short log. And then finally, something I'm not actually going to go into now, but do go and look in the notes, and that's the ability to filter stuff. So you can go and do a git log and work out, just show me the commits that Yasmin did, or just show me the commits that Xanthi did. You can do some grepping based on the content of the commit message. You can specify I only want to see stuff that's related to a particular file, and the list goes on. You can also search for the actual content of the commit as well. All of those things are in the notes. They're really quite simple to do, but I don't think that you need to sit and watch me type more out. Let's get on to something a bit more exciting. So moving on, so still talking about visualization, then what we've done so far is look at how do you do it in text form. But more often than not, I think it's really useful when I'm doing this kind of stuff. I like a very much more visual approach, because Git histories and things are a very visual kind of thing. At the moment, I don't really understand what's going on in this repo. And I use a tool called GitUp. There are many, many tools. I used to use SourceTree, there's Tower, there's many different things that you can use. But for the purposes of this, we're going to use GitUp throughout, and that's one of the prereqs, and you probably should have installed that. And in order to see, if you followed the instructions and installed the command line tools, then to see what's going on with this repo, I can just type GitUp in the command line, and it will open something like that, which is the smallest thing in the world. Let's move that and have a zoom on it. So what you can see here is it's visualizing the list of commits. These are the different branches, and he's showing the different commits along the side. So it gives you an idea of the tree structure of what's going on. And then within each one, I can select it, and it shows me what the commit message is. Zoom in a bit more. So you can see that. So that's the commit message, and I can go up and down, see what the different commits are. This I find quite a good way to actually visualize the entire repo, and it's what I use. Now GitUp can do a hell of a lot more. In fact, if I get the context menu up and zoom out a little bit, you can see I can do all kinds of things. I can fix up, I can squash, I can change the order, I can swap with the parent, swap with the child, I can do cherry picking, I can do reverting, I can do merging. You can do pretty much anything that you need to in Git, in GitHub. but I think it's really important to understand what the hell does this all mean. So we're going to stay mainly in the terminal and using GitHub to visualize it. And once you get that, then you can use GitHub to do these different bits and pieces, or your other tool of choice. They're all fundamentally very similar. OK. So now we're going to jump on and do some working with different branches. So we go back to the terminal. And I'm going to check out XWEven. So I'm going to quickly, let's have a quick look at these different branches here, and I'll explain roughly what's going on. So the algorithm that we're using, hello, Marin.
Quick question.
Yes.
There seems to be more branches with GitHub than now than from what we saw from GitHub, the command line.
Right, yeah. So when you're using, if I went back to the command line and type git branch, is it -L? There, that's the list of the branches. That's the thing that I didn't mention about the log. Only shows you a history of where you currently, how did you get to here? So you see your history of all your commits and then the mergers and branches that went into it. So this is how you would see all of the different branches. Now these different branches here, they've got funny names so that I remember who wrote them, because it's all a little bit weird. The way that I'm going to approach this, because we're not going to talk about the idea of remotes too much, but the idea is that each of these ones that have a prefix of W, then W means Will's branch, X is Xanthi's branch, Y is Yasmin's branch, and Z is Zach's branch. They're all we're pretending as if they're local to that user, they're working on them. The master branch we're going to kind of pretend is the remote one, it's the golden one that you can't rewrite history, right? Once you've pushed to master, you can't touch it. But these other ones we can do what we want with. Each of these represent what that user's been doing, and then we're going to go through and take their bits of their algorithm to fit it in. So we're going to start out with Xanthi's branch working on doubly even. Doubly even is one of the ways that we use to generate a magic square. So we're going to go in, git checkout, X doubly even, so that's Xanthi's doubly even branch. And once you've done that, it tells you that you've switched to that other branch. And if I take a look what's in there, I can see I've got a file called ignore me, a file called license, and a file called magicsquare.swift. What I should have done, 2 seconds, you don't have to do this because I'm just going to go back again in a sec. If I look what it looks like on the master branch, you can see I've got a license file, that's the same. There's a readme, which has appeared in master but not in Xanthi's branch. And then magic square is not called magicsquare.swift, it's just magic square. So Xanthi's gone off and started work, but we've actually decided we're going to use a different file name. So I'm going to jump back into Xanthi's double even. So that gives us some kind of idea of what needs to happen. Now what I'm going to do, which is what I'm sure you're kind of used to doing, is that I don't want to merge this into master. I want to merge master into me, into this branch. I fix all the problems, and then I can push that to master. You don't try and do mergers directly into master. Well, I wouldn't. So I can do that with git merge master. That's going to say, I'm stood here, merge master into me. So once I do that, it's going to give me it's going to throw me into a text editor so I can make a commit message. Now, probably your text editor is Vim or VI. I think that's probably the default. It's certainly my default. If it isn't, then good luck to you. Well, no, not good luck to you. You've probably felt easier than what we're going to do now. You can change your editor really easily, and I've written in the notes how to do it. You can do it as an environment variable called getEditor or editor, or you can do it on a global scale in the git config. If you want to know how to do that and switch to using TextEdit or some other thing, then do go and look at that. Otherwise, we're going to work in VI, so good luck, everybody. Now, I'm happy with this commit message, so I'm just going to quit out of there. I'm going to press escape, I'm going to press colon, I'm going to do W, and I'm going to do Q to write and quit. And that will make that merge commit message. And if I now do git GL, then we can see I've got this merge branch master into XWEven. That's the new commit we've just made. All great, that's what we'd expect. Okay, this is, if I now ls that and see what's in there, well, now I've got magicsquare.swift and magic square. Well, I don't want that. I want to tidy this up. So there were no merge conflicts, but this isn't quite what I want to do. So I want to take a look at those and fix it up. And I'm going to do that in a text editor. Now, I use Sublime Text for text editing. You can use whatever you would like to use. So if I do STT and do this, and then I can see, if I do that, does that fit on the screen? Yes, but it's tiny, but that's okay. So I can see the contents of my directory is up here. Okay, so I've got these different files, and I want to take a look at what's in magic square.swift, and then zoom that in. So we've got this function x doubly magic square, what it's called, doubly even magic square function. I just want to take that and put it into the magic square file. So whatever text editor you've got, then just grab this function, this Swift function, doubly even magic square, cut that out, and then jump into the magic square file. So that's over there, so I've just selected the magic square file. And then I'm just going to make this look like Swift, so there we go. And then you need to add that file, but it needs to go above where it says generate magic square. So on line 27, you need to put a load of new lines in. Is this big enough, right? Everybody see this? Yeah? Good. And I'm going to paste that in. So now I've put x doubly even magic square. Now there's a little bit of weirdness about where you need to put it because we're using Swift scripts and you have to define things before you use them. So we need to put it in the right place. But once we've done that, then I can save that file. And then we're going to commit that change. So let's jump back to the command line. On my shell command line, it now has got this yellow X, which means that I've gone dirty. This is a dirty working directory. And I'm going to git add magic square. Is this too low down the bottom? Can you see it? Too low, right? Shh. How's that? Okay. So git add magic square. And then I'm going to commit that. So git commit -m, and I'm going to make a commit message up, adding doubly even, I can't type, magic square. Now at this point here I will point out that I'm using -m to give the commit message in the command line. You should probably write sensible commit messages using a text editor, but we don't have all day and you don't want to watch me type badly all day. So run that and it tells you what it's committed and that kind of thing. Now I'm going to take out that magic square file. So if you remember, they've got this magic square.swift. I don't need that because I've taken what I need from it. So I'm going to do git rm magic square.swift. And now I've done that, once again, I've got a dirty working directory. So I'm going to commit it. So git commit -m, removing, oh dear, file. And then one more little thing to do inside Swift is, now that I've added this function, I actually need to add a call to it. Now feel free to go and jump through all of this code and understand what's going on. It's not very complicated Swift because I'm quite stupid, but it's really, what we need to do is inside here we've got this generate magic square function. It's now in my code starting around line 49. Then I've got this doubly even. Doubly even means that we can generate a magic square that is divisible perfectly by 4. So that fits this case here. So I've got error, this is not currently supported. So case 0, switch that out to say return doubly even magic square of the order. Tiny bit of fairly easy to understand Swift. I'm going to save that. Everybody got that? Yeah. And then I'm going to jump back to the terminal and I'm just going to commit that. So that's git add magic square, git commit -m, and adding call to function. Okay. Okay. So now, I mean, all of that stuff I'm imagining is fairly understandable, fairly easy to go with. I'm running out of time, but I'm going to keep going because this is really important stuff. This is now onto the world of git ignore, right? So if I have a look, I have a feeling that I've got a git ignore. I want to cat a git ignore in here. No, not that. Git ignore. So I have a git ignore. It's got a load of stuff in it, but the important part is down at the bottom. We're ignoring this file called ignore me. Now, if I jump into my text editor and open up ignore me, and it says this file should be git ignored, I'm going to add a new line at the bottom, adding a new line, and save that. Sorry, am I going too fast? Just save that file, I've added a new line to it. Go back to my terminal and go git status, and it's telling me in the largest font in the world, so we can't see it all. It says here, on branch XW even, fine, changes not staged for commit, modified, ignore me. How, why? Because ignore me is in the .git ignore. Why is that? Well, git ignore was in the master branch that we merged in, and in my XW even branch, I'd already committed a version of ignore me. It was already being tracked by git. So now I've got a git ignore that is being ignored because we're already tracking that file. Now, there are 3 different ways that we can deal with this, one of which I'm not going to show you now. We'll move on. If you want to look at it, I'll explain what it is, but if you want to have a go with it, then do go and read the notes. And that is the ability to say, pretend that this file hasn't got any changes in it. And you do that with a thing called git update index, assume unchanged. And what that means is from that point forward, Git will always pretend that whatever you do to that file, it's not changed at all. You can then, so you can do what the hell you like with it, and it'll just pretend it's not changed. Then to bring it back in again, you can do git update index no assume unchanged, and then that will then ignore that kind of that trigger and allow you to start tracking the changes again. So you can do that on a case-by-case basis, but that file would still exist in, that would only work for your repo. Somebody else would have a similar problem. Option 2 is to uncache the file. And what that means is you could just go, don't run this, but if I go git rm ignore me, then what that will do is it will delete that file and it will track in Git the fact that that file has been deleted, which is part of the way there. But even though it's called ignore me, I do actually want to keep that file locally. It shouldn't be in the repo, but I want to keep that file. Think for something like secrets. So what you can do is instead of git rm ignore me, if you do git rm -- cached ignore me, so ignore me is the name of the file, right? That's helpfully named, so it looks, well. What this does is it keeps it in the working directory, but it saves in the index that this file has been deleted. So if I do that, run that, and then go git status, and you can see that it's deleted the ignore me file. But if I type ls, you can see the ignore me file still exists. So what we've done is told Git, pretend this file has been deleted, but don't actually delete it. And then from that point forward, git ignore will take over and it won't track those changes. So now I've done that, I need to commit that, because that's a change, so I'm just going to call that remove ignore me. And there is, as I mentioned, there are 3 different ways of doing this. That's 2 of them that I've discussed. The third one is something that you will look at in the lab, which is to do with this ignore file. It no longer exists in the Git repo from now, but it still exists in the history. Now, if this was something that involved a load of secrets, I would want to remove them completely from history. And you'll see how to do that in the lab. Now we finish this branch, the doubly even branch is done, we're all happy with this, so I can now merge that into master, and then we're done. So first of all, I'm going to check out master, then I can go git merge x doubly even, and what this will do, yeah, no, this is fine, git merge x doubly even. And what that does, you can see there it says fast forward, and if I jump back into GitHub, and this has been working on updating stuff, you can see here that master and XW even are now in the same place, but there's no merge commit. That's called a fast forward merge. I'll explain what that is in a minute. But if you don't want a fast forward merge and you want a new merge commit created, then there is a way of doing it with git merge -- no -ff, and then the name of the branch. OK, so back to some slides, and I'll explain in a little bit more detail what no fast forward means. Right, so merging then. We looked a little bit at this earlier on. We have people doing some work, so I'm going along doing my work. Then my friend comes along and she branches off from the work that I'm doing. She then goes and does some work, and then I carry on at the same time. And the cool thing about Git is the ability to merge this stuff back in. Now the way that that does it, and the thing about Git, and back in the day when Git first came out, I just realised, am I supposed to have a break here? Sorry, Tammy. Was I supposed to stop for a break?
If you guys want to take like a minute break to go for the restrooms or check your email, we can do that. If you would like Sam to continue, we can do that as well.
I'm sorry, I got a bit overexcited
So let's
in my
go,
own voice.
because we're already a couple minutes over, so we'll go. We'll keep
Okay.
going.
Merging then, right. So we've gone off. My friend's done the yellow branch, I've done the blue branch. The point of merging is being able to join them back together. And the thing that was cool about Git when it first came out is it knows all about these branches. It knows the history, and it does something called a three-way merge. Any two commits in most repos that you'll ever see always have a common ancestor of some sort. There will always be at least the commit where, as long as you're following the branching and merging type thing, every two commits will always have a common ancestor. And that means rather than just having the code in the yellow one and the code in the blue one and having to work out how the hell do I join those together, you've also got more information because you can go back and say, well, at some point these were the same. And then something happened to get to the blue one, something happened to get to the yellow one. I can take those two diffs, as it were, and kind of join them together. You get a lot more information. Now, this isn't unique to Git at all, but back when we first started doing this in Subversion, this was quite difficult. You had to manually say, what's the common ancestor in some sense. Git does all of this by design. Then it does that three-way merge. Now, not to say that it always gets it right. You still get merge conflicts if you're both editing the same line. It does it on generally a line-by-line basis in text, and in binary, it has no idea and just ignores it. What the hell is that? Fast-forward merging. We saw that very, very briefly, the idea that you can do a fast-forward merge. So let's look at what that means. I'm going along, there's master, then I decide that we need mega feature. So off we branch, we start working on mega feature, and then we do a couple of commits on mega feature. Now what I want to do is say, well actually, I'm happy with this now, this is done, I want to merge it into master. But this merge master, nothing's happened on master. So in actual fact, rather than doing any merge stuff, we don't need a new commit, we can just move master to the end of there. That is a fast-forward merge, right? Because we're saying, I don't actually need to do anything, so I can just go from one to the other. Fast-forward merge. And the no fast-forward, like I mentioned before, this is what Git will do by default. If you don't want that, you can say no fast-forward, and what that will do is it will create an low. Is that better? Hello. You can hear my tones now. A no fast-forward merge will create an artificial merge commit. So what it could have done is create another commit over here, which doesn't really do anything, but it just joins those two things together. Now, rebasing. This is what we're going to look at primarily in the next demo. We've got the same kind of situation. I've been working on the yellow branch. I've gone over here. And my friend has been working on the blue branch. Notice I seem to have a lot of friends in this talk, which is not representative of real life. So I'm on head over here. This is where I exist here at the end of this yellow branch. And what I could do now is merge that back in. So then we'd have another commit on the end of here, and we'd branch that back in. But maybe I don't want to do that. Maybe that's overcomplicated, and you don't have to do that. What you can do is this idea of rebasing, where I take this is the first, so we find the common ancestor, and then we take the first diff to get to the first commit where it branched off, and I just replay it on the end of the other branch. And then I take the next one, and I replay that one. And then finally, I move where head is pointing to, from the one branch down there up to the end there. So what we've now got, these two commits are completely new. They're not these commits, they're new commits, but they represent the same work that we did, the same changes, and now rebased onto the end of here. And the idea of rebasing is saying, take this branch that we've got here and change its base. Change it from here to here. And that has the advantage that you've got a much simpler looking tree, right? We haven't got all of these branches, which can sometimes be advantageous. This is only one form of rebasing, and we will see another one. It's one of the most powerful tools. But at this point, I will mention that anytime you do rebasing, you're rewriting history. And with great power comes great responsibility. You can't rewrite history if somebody else is already using that history. You can't go and say, well, I've been working on all of this stuff. I've shared it with all of my friends. They're all working on top of it now. And I'm going to go back and change some stuff that you did earlier on. That won't work. You can only use rebasing if it's only you who's been doing it, or you've got an agreement that I'm going to go and change this history. And then finally, the other little thing that I'm going to talk about very briefly is cherry picking. Now imagine we're back in the same situation, and my friend created something in this blue commit here. Is it that one? I'm guessing. Don't know what the next slide looks like. I think it's that blue commit there. I don't want all of the stuff that she's been working on. I just want that one commit. So I could rebase. I could merge. But I only want the one thing in that one commit. And what I can do is take that and just chuck it on the end. Similar to rebasing, I find out what was created in that commit and I apply it to my own branch. That's called cherry picking. That can be really useful for, we use that in, use it quite regularly because we've got a system of, we have a development branch which is always on the staging server, we have production, a master branch which is what's in production, and if you push something to staging and then you need to do a hot fix, you'll push that onto development and then you might need to cherry pick it straight onto master. So this is quite handy for just picking that one commit that you want. Okay, so demo 2, we're going to look at rebasing instead of merge, which is the first rebase that I talked about. There's interactive rebase, which takes the ability to rewrite history to the next level. And then finally, we'll look at cherry picking, which was that last thing that I showed you. So demo 2 uses exactly the same code, the same, what's it called? Repo that you've been working on. So if you've been following along and you've got all of the mergers and things in, you can continue exactly where you were. Otherwise, if you've had any problems with that, jump into the demo 2 folder, open the starter zip file, uncompress that, and then that is the Git repo in the state that it currently should be. Let me find my rules so that I know what I'm doing. Grab you. Okay. So let's grab up this for a second. This is what we're working on. We've got to merge all of these branches. We've got to join all of these branches back together. We're now going to take a look at Will's branch. Will has been working on, if I zoom in a bit more, Will has been working on, so we've got various different things going on. We've got some people who are generating code to create magic squares, and then Will has done some stuff where he can check that if you give it a two-dimensional array of integers, that it is actually a magic square. So there's two things going on. Will's been working on that. And at one point, Will did something. Zach wasn't very happy with it, so he refactored it over here. He branched off what Will was doing, he refactored it, and then if I look at the diff over there, he's just taken a little bit of code, thrown some of it away and written something a bit simpler. So that was in a commit that Will had done, no, sorry, Zach had done, so this bit here is what we're concentrating on. What I could do, is I could merge Zach's branch, Zach MS check, into WMS check. But then I've got this kind of pointless branch thing that's merging in that doesn't really mean anything. What I can do instead is say, actually, I want to rebase, I want to take all of these commits after Zach branched off and just replay them on the end of Zach's branch. So to do that, zoom back out, we're back into here. I'm going to first of all check out WMS check. So that's git check out WMS check. So we're now on that branch WMS check. And then I can say git rebase ZMS check. So that's saying I'm on the WMS check branch and I want to replay all of the differences on the end of ZMS check. ZMS, no, Z. And then if I look at this code, what it's doing here is it goes through, it rewinds first, so it rewinds the head where I exist all the way back and it replays the work on top of it. And you can see it running through all of these different commits one by one to apply that commit on the end. And if I take a look inside GitHub, you can now see that ZMS check, sorry, this is tiny, isn't it? There, how about that? ZMS check, which is this dotted green line here, still points to this commit, but now we've got all of these other commits that we had before are now on the end of that, and there's no branching there anymore. We've rebased on top of that. Now, the thing that I was really worried about when I first started using rebase was, yeah, but we've now lost that information about when that commit was and who did it, because I've come in and broken it. But actually, that's still stored. So if I take a look at the head, and I push the spacebar, then that shows me what the commit was. But the important thing here is in the commit message, we've got something here that says that who committed it, so Will actually wrote the commit in the first place. Hello?
I wasn't supposed to actually interrupt you.
Oh, okay. Oh, okay. Bear with me. Right, I'll just finish this very brief bit and then we're going to have a tiny little break to fix my microphone. We can still see who wrote the commit in the first place. That's the author, so that's Will at example. And then, but you can see the committer, so I actually committed it and I committed it just now. That's really helpful to know that information. Now, because we've done that, zoom back out, we're now finished with that branch, so I can go git rm, no, rubbish, git branch -d zms check, like that. And that's now got rid of that branch because we don't need it anymore. And at that point, we'll take a very short break whilst somebody comes and fixes me. Right, so we know how to do rebasing instead of a merge, so the kind of the relationship between merging and rebasing, but that's just touching the surface. That's a terrible, what's the word? That's just a tiny part of what you can do with rebasing. So, if I do git gl, which you remember is that thing that we made before, then we can see, if I take this down a little bit, these are all the commit messages. And normally you wouldn't name commit messages like this, but I did this so that we can actually do this. There are lots and lots of commit messages here. Some of them are util ones, some of them are check ones, and some are util, some are check, and they're all kind of in an order, but they're all interspersed. Now what I want to do is, in my mind there are too many commits here. If I want to push this to somebody else to review, then I would quite like them to have like 3 commits that make some sense. So here's a coherent piece of work. You can understand what this commit is, and then you can check that, and you can move on to the next one. At the moment, this is what it looks like in my head. This is the way I did it. It didn't make any sense. Or I should say the way that Will did it, obviously. This is Will's branch. And it doesn't really make any coherent sense. Now, what you can do with rebasing is rewrite history. And I can take those and squash them all up. So rather than having 20 different commits, I can turn it into 3 commits that are all coherent in what they're actually offering, which makes code review much easier. It makes it a lot easier to understand what's going on when you come back to it later. Now, the way that we do this, if I jump down a little bit, is by doing what's called an interactive rebase, which is the most powerful version of rebase, I think. And what that does is I tell it, from this point forward to all of the commits after that, I'm going to do something with them. I want to play with them. I want to edit them, and I can do all different kinds of things that you might want to do. I can join them together. I can reorder them. I can change the commit message. There's a hell of a lot of things you can do, or you can just jump in there and completely rewrite the commit. So what I want to do with this is take from this commit here, this removing temporary text. I'm happy with that one. Everything after that, though, is a mess, and I want to tidy it up. So I've selected the, what's this called? The commitish, the beginning of the SHA-1 hash. That there, I want to copy that, because from that point forward, I want to edit them. So I've selected that. I'm going to Q to get back out of less, and I'm going to type git rebase -i is for the interactive, and then put in that commit hash there, 73B3665. And what that's going to do when I run that is going to start an interactive rebase. Has everybody got that? Because once we've jumped over there, then we'll be a bit confused. Yeah? Happy? Grand. So if I press enter, what that does is it throws me into my text editor. So we're back in VI. And it's listed in there. Each line is a commit in that big story. I can scroll up and down them. Now what I can now do is see each line begins with the word pick, then it has the commit hash, and then it has the commit message. Now what I can do with that is I can replace that pick with different words. And we'll look at some of those different words later. The first thing that we're going to talk about is reordering commits. So what pick does is it says, keep this commit. I'm happy with this. I want to keep it. This file is treated like a script. What will happen when I save and quit this file is Git will go down this file and run it as a script and do what you've told it to do with each line. Pick says, keep this commit as it is. What I'm going to do in the first instance of this, I just want to reorder it so that we have check 1, 2, then we have a load of util ones, and then we'll have the checks right at the end. Does that make some sense? So I want to do checking first, then some utils, and then there'll be a bit more checking to do at the end. We're going to reorder it, and then we'll come back to it later. To reorder, all you do is reorder the lines. So I'm sure you're all Vim aficionados, but here we go with some line reordering. I want to keep check 1, 2. Then I want to keep util 1, 2. Then I want to take util 3 and 4. I'm going to take them out of where they are and put them in the line above. To do that, in VI, make sure you've pushed escape. Then type D1, enter. What D does is yank or deletes that line. It takes it out and it's put it in the clipboard for better way to say it. Then go back up to util 02 line and push the lowercase p, and then that pastes back in, and the lowercase means it goes on the line below. So you can see now we've got util 1, 2, 3, 4. Now jump down to the line that says util 5. How many lines do I need? I need 5 lines. So I want to go D4, enter. Then jump up on the line util 4, type lowercase p. Jump down to util 10, type D twice, so DD. Then up on util 9, type p. This is fun, isn't it? On this util 11 line, DD, jump up to util 10, p. Right down to the bottom now, DD on util 12, and p on util 11. Does that make sense? Like, this is all kind of... I'm trying to avoid us battling through how to use Vim. Like, you could use like a proper text editor, but being as this is the one that's here, then this is the easiest way to get going, right? So now if I look at this, I've got check 1, 2, util 1, 2, all the way up to 12, and then I've got the rest of the checks at the end. So all I've done is reorder those lines. I mean, it doesn't seem like that because I've been talking about it for such a long time, but literally, we've just reordered those lines. Now, if I push escape and I save that file with :WQ and hit enter, what this now does is it says it's rebasing, and it goes all the way from 1 to 20, and then it says it's successfully rebased it and updated the refs. So what that means is it's gone through and it's replayed all of those commits in the order I told it to, and then it's moved the reference, the pointer for that branch from where it was onto the new thing that it's just created. Let's see what that actually looks like if I type gitgl again. You can now see, working backwards from the head of WMS check, we've got check 8, check 7, check 6, all the way down. Then we've got 12 through one of utils, and we've got check 1, 2. So we've reordered those commits, which is a good place to be, right? Now it's starting to become a little bit more coherent, this story that we're telling with this code for somebody else to review. It's no longer just the way that my head was working, it's now becoming a little bit more thought out, which is not the way my head works. But it's still not that great, right? We've still got about 20 commits to do essentially 3 bits of work. So now I want to go through and I'm going to merge those commits, I'm going to squash them together. Once again, I'm going to do a git rebase, and I want to keep the same base of that. So I'm going to do git rebase -i, same one, 73b3665. And I run that, and it'll give me the same kind of thing. It gives me this text file, and it's got the order that I just changed it to, right? That's exactly what I want. But now I'm going to do some stuff like squashing and the such like. Now, there are different things that you can do. The first thing, so pick, remember, keeps the commit exactly as it is. The first thing we're going to look at is I want to keep that commit, check 01, but I don't like that commit message. It doesn't make any sense. So I'm going to change pick to reword. In VI, type CW, and then write the word reword. And escape so that you can start moving around again. So what that means is when we get there, it's going to throw me out into a commit message editor so I can change the commit message. And then the commit itself will remain the same. This next one, I want to join that with the previous one. I want check 1 and check 2 to become a single commit. So to do that, I'm going to change pick. Now I could choose squash here, but I'm going to choose fix up, and I'll explain what the difference is in a second. So I'm changing the word pick to fix up. Now what fix up does, no, let's start with squash. What squash does, it takes 2 commits, it just joins them together, and it joins the commit messages together as well. Fix up is almost exactly the same. It joins the commits together, but throws away the commit message of the second one. We don't care about the commit message. I don't care about check2 adding comments to divide code. I care about the content of that, and I want to join it with the previous commit. Now, the next one, all of these util functions, I want joined into the same commit. And I can do that. I want to keep the first commit, but again, I want to reword it. And then each of these, we're going to look at it slightly differently. We're going to squash these. We're not going to fix them up. And that's just to show the difference between the two. So I'm going to CW to change the word, type squash in there, and then escape. And then those of you who are VI aficionados, if you go to the beginning of the next line and push dot, full stop, period, something like that, on each of those, and you're just changing the word pick to squash on each of those. Now, alternatively, you don't have to type the entire word. You can type just S instead, or F, or R, or P. So all I'm doing there is squashing these 12 util commits into one single commit. And then we're back down to the check ones. And then finally, at the end, we're kind of understanding this now. This is our third commit. We've done one commit that's checking. We've done one commit that is util stuff. And then we've got one final commit now for all of the rest of the checking code. So I want to pick this commit. And then each of these after here, I want to change to fix up, which again, I change. And then I change on each of these lines. OK. Done. Does everybody have something that bears some resemblance to that? It's not the end of the world if you don't, because as long as you've got these commits in some form at the end, then it will be fine. But that's what we've got. That's written a script, and now we're going to go and execute that script. And we do that by saving. So we do write quit, and then Git will start working through it. And it's got to the first one. Remember, the first one was, I want to reword this commit. So I'm going to take that there. If I type a capital S, then I can start typing my new commit message, adding the structure. I mean, you'd love me if I was on your team writing commit messages like this. So reword that, and then do write quit, so :WQ, and then that will move on. This is now, remember, I wanted to reword the first of the util commits as well. So do the same in there. Do utility functions. Now it jumps through a load of commits, and it gets to the end. Remember, I squashed all those commits. All those util commits got squashed. Instead of fix up, it would have just continued and jumped on. But because we squashed them, we now have the opportunity to create the commit message that is the combination of all of those separate commit messages. So you can see it's got the utility functions, which is what we reworded the first one. Then it's got util 2, 3, 4, all the way through to the end. So at this point here, you can do some changing of it. You can grab those things together. I don't really care here, so I'm just going to be happy with this. So I'm going to jump out of there, again, save and quit, WQ. And then it gets all the way through to the end, and it's now finished running that script. So what's that done? Git GL again to show what it now looks like. Remember before, after this 73B3665, we had about 20 commits or something all up. We now have just 3 commits. We have the adding structure commit, which is the check 1, 2 joined together. We have the utility functions, which is those 12 commits. And then we finally have check 3. Remember I chose pick instead of reword, so it just kept the existing commit message, which is a pretty terrible commit message, but it demonstrates what it means to do pick. So we've taken that big chunk of 20, dropped it down to 3. It's much, much simpler. OK. Now we've rebased that and we're finished with it. What I need to do is to put that into master, right? We're now happy with this WMS check. All of that stuff's been done. It's time to merge that into master. Or in this case, we're going to rebase it into master. So I rebase it onto the top of master. So I've got these check functions. I'm going to stick them on the top of master. So to do that, git rebase master. Same as the thing we saw before, right? Exactly the same. The difference here is that I have a feeling, yes, we're going to get some merge conflicts. Why would you get a merge conflict when you're doing a rebase? Well, we're taking this code and we're going to try and apply it onto the end of existing code. Now, if those two things contradict each other, then that is exactly the same as a merge conflict. As it replays your changes, it's just doing a three-way merge. The one thing that I think is important to point out at this stage, and I could skip it, but I think it's quite important. Are you aware of ours and theirs when you're doing merging? So if I do a merge, and I'm on a branch, and I say, merge this other branch into me, then what that does is it takes me, where I am, ours, and it takes theirs, which is the other branch, and it merges it into me. If you then get a conflict, you can go and see this is what a conflict looks like, and you can see this is ours and this is theirs. I'm on this branch, this is mine, this is ours, and this is theirs. All kind of makes some sense until you get to merge conflicts when rebasing. And now, ours and theirs are switched, and it never seems to make sense. The reason for this is I'm on this branch, and I want to rebase on top of master. So in your head, you think that, well, ours is the branch I'm currently on, and ours is the branch I'm currently on, and theirs is the branch that I'm rebasing on top of. That's wrong. That's what it is for a merge. But when you do a rebase, the first thing you do is move where you're sitting onto the branch that you're rebasing on top of. And then you take the code of the branch that you were on and start merging it on top. Remember, you replay each of those changes. So now ours is the branch that you're rebasing on top of, and theirs is the branch that you were on. So all you need to be aware of is that ours and theirs is a bit confusing because it switches if you're rebasing and if you're merging. Hopefully that's useful. Right, we can tell we're currently in the middle of a rebase, and I've got a merge conflict. Now, this patch failed, and I can have a look at this patch, so it tells you this is where the patch is. So I'm just going to select that and cat it. And it tells me that, well, what this did, this thing that it can't apply, this patch is just deletes hello from Swift. Now, for time's sake, we're just going to kind of skip over this, because I can tell you for a fact that shouldn't be in there. It can't apply that patch because it can't find that code in the one that it's applying to. So what I can do is say git rebase -- skip. And what that means is I don't care about this patch. This commit doesn't mean anything to me. Just get rid of it. So I do git rebase skip, and then that will jump over that particular commit that you're trying to rebase. Now the next one, there's a bit of a problem with this. And we're going to look at fixing it manually. If I jump into my text editor and look in the magic square file, then you'll see these kind of weird, funny arrow things that you're probably familiar with when you've done any merge stuff in the past. Head means this is the thing, this is ours, as it were, and then down at the bottom here we've got what's theirs. Now what I actually want to do with this, I can't remember. You'll fix this one. You want both change sets. Ah, right, OK. So this thing here that says function check for magic square, I want to keep that, but I don't want it where it is now. So I'm going to copy that code. This is right down at the bottom of the file. Cut that out. And then I want to paste it just after here, where we check we're checking the arguments that have been provided. So in here, before doubly even magic square, just paste that in there. So the magic square check functionality jumps in there. Once I've done that, I also need to delete the change annotations, the merge annotations. So the head at the top, right down the bottom of these two bits here. Once I've got rid of those, I can save that file. So I've manually resolved that merge conflict, jump back into the terminal. I'm going to add that. So that's git add magic square. So I'm staging the changes that I've made. And then I can do git rebase continue. And that is the equivalent of committing that change and continuing the rebase. And you can see that the other three functions, the other three commits we had, work perfectly well. And I can test that this is working by running magic square 5. I think we can test it. Let's see what it does. Ah, no, we can't. We've got more problems. I'm way over time. What time have we got? We've got 20 minutes left. I'm going to keep talking. And for that, I apologize. So I just need to fix this. This is a bit of Swift fixing. So this came from because we were doing two different things at once. We just got to tidy the Swift up here. Basically, we used the constant name square in both of the different branches. If I jump into there, you can see that the error is it's redeclared on line 160. What I actually want is to get rid of it on line 89, I think. So if I jump in here and find line 89, it's around here. This section here that says running some samples, I don't need that anymore because I'm building my own samples. The code is now doing this for me. So grab those two chunks there. Is that big enough? Yeah, good. And then delete that. So I don't need that anymore. And then I want to type some stuff right at the end of the file. So now, down at the bottom here, let's add a few more lines so you can see it. At the moment, what this is doing, what this is going to hear is, this here will generate the magic square soon. It doesn't yet. And I just want to, once it's generated, I want to check that it works. So there's a bit of Swift to type now. This is the only bit of code we do, I think, in this. So if check for magic square, square. So if it works, then we'll do print yay magic square. Oh, Jesus, magic square. And then else print nay not as magical as you thought. O-U-G-H-T. Okay, so that's just changing some stuff in there. Everybody got that? It's really simple. We're just checking whether this thing's actually working using this new function we've just merged in. If I jump back into here and rerun the magic square 5, although it's generating a magic square of order 4, which is something we'll address later on, it is now working and it is checking, it is confirming that that square is magical. So the final thing to do with this particular thing is to add those changes and commit them. So git. So this is the same old game that you're used to playing. Git add magic square, git commit -m, checking generated magic square. Then, now that I've done that and I've committed it, I want to merge this back into master. Git checkout master. Now I'm just going to go for a merge here. It'll be a fast forward merge, I think. Yes, indeed it is. And now I've finished with that branch. So I can go git branch -d wms check. That all makes sense? That last little bit there, very simple. We're just committing it and then merging it in. And if we take a look at what this is looking like now, it's looking a lot tidier. We've got rid of loads of the branches. We've only got, well, that one there can be deleted. Sorry, pointing here isn't very helpful, is it? XWEven can be deleted now. We're not using it. We've got 2 more to go. And then we're into master, and then we'll be done. OK, I'm going to talk about cherry picking. I could skip it out, but I think it's quite interesting. And the lab will be a bit shorter. But you can do that in the comfort of your own home or in the lab over the way afterwards. So cherry picking, I'd explained what cherry picking was before. Let's see it in action, and let's try and see what's going on. So first of all, back into the terminal and type git checkout z singly even. This is this is Zach's branch. He's been working on something called singly even ones. So we had doubly even, which is ones divisible by 4. Singly even are those that are even but not divisible by 4, like 6 and 10. Check out his branch, and then try and run magic square with the number 10. See what Swift says. Use of unresolved identifier odd magic square. Let m equal odd magic square. And that's because this function that he's written relies on the ability to generate an odd-numbered magic square, which he hasn't done. He knows that somebody will write this function, but he's not written it himself. Well, in actual fact, somebody has already written it. If we take a look back in here, Yasmin's been doing this. Yasmin has a branch here called yodd. She's been doing it, and in fact, this commit here, adding the odd magic square function, contains that complete code required for that change. We don't need these two. Adding a call, don't care about that. Updating the run arguments to demo it, don't care about that. We care about just this single commit here. I don't want to merge it in, I don't want to rebase it, I just want the contents of that commit, which is what cherry picking is doing. Now, that commit is called, has a hash of E44990D. And if I jump back into here, I can say, I want to cherry pick that. So we go git cherry-pick, and then the name of the hash of the thing we want, which is E44990D. Could not apply it because we've got a merge conflict. Now, we've seen a couple of different ways to do merge conflicts. I'm going to show you a third way. So we did one where we just skipped it. We did one where we fixed it manually. I'm going to show you a way using file merge. Now, if you have better apps for doing mergers, I suggest you use them. But here we'll look at file merge, which is the one that comes with Xcode. If I jump back into here, this is into GitHub, you can see down at the bottom, it says we're on branch Z singly even, and we're doing a cherry pick is currently in progress. If I go into this little button here, which is the select, then you can see that it's got the magic square file. The orange means it has conflicts. It means that this file has changed both in the original one and in the one that we're trying to cherry pick in. What I can do is click the Resolve in Merge Tool button, and that will open File Merge. Or if you have a different program, it might open a different program, but the functionality should be roughly the same. And what you can see here is that it found these three different chunks that are different in the two of them. It's found these two ones at the bottom, and it's confident that it knows what to do with those. It knows which one it should select. But this one at the top, it's not sure about, because we've got here singly even magic square, but we've also added odd magic square. Now, I want both of those because I'm merging them in, and I want to put them in a particular order. That's really important because it's a Swift script. And that is, I want the odd magic square, and then the stuff over here. So if I select this, so this red one means it's a conflict, select it, you can see the arrow there, down to the bottom right, and you can see this actions menu, hit that, and I'm going to say choose both, write first. What that means is it's going to take the code from the right-hand side, the odd function, and then it's going to put the code from the left-hand side immediately after it. As I do that, I then see that the arrows change, and it's now got both of them with the one on the side that's going first and the two on the other side. To finish this off, I do save, so Command S, then Command Q. And then if I jump back into the terminal, I say git add magic square. So that's saying that I've now resolved that conflict. And then I git commit it. That tells me that this is the commit message I can put in. I'm happy with that, so I'm just going to save and quit. Now, let's run that again. Magic square, with a 10 on the end. That's a singly even number. There, we've now generated a magic square of order 10, because we've taken the odd magic square function that somebody else wrote on a different branch and pushed it into my branch so that I can use it. And that is, for now, for like the next nearly 10 minutes, all of my speaking. I think we're now finished with that, for you're very lucky people. So now you can move on and do the lab. The lab should be 20 minutes. I think it will take less time than that. What you're going to do in the lab is basically finish this lot off. You've got here these branches that are going on. We basically need everything into master so that this works for everything. So if you follow it through, you will learn how that we can finish off some merging. There's a bit more conflict resolution to do. There's some stuff to do with undoing, and how do you undo stuff in Git using the ref log, which is super powerful, really handy. It's basically undo for Git. Here's some stuff about how to do reverts. It's some stuff about how to do what hard, soft, and mixed means. There's a whole lot of stuff in the lab that's really useful, and at the end it's kind of thrown to you guys just to finish this off. Now, if you get stuck on this, remember that the final project for this is a zip file with a Git repo in it. You can just take a look at that, and using all of your new skills, you'll be able to look and see actually what were the changes that went in and how did they go in. So if you take a look at that, I'll have a wander round. I guess probably about 8 or 9 minutes left on this, so if you've got any questions, then do give me a shout, and if not, we can always go over it later on. Thank you. Okie dokie then. Well, I'm really sorry that that lab, Lab 1, not whatever name we're coming up with, that lab wasn't the length of time that it probably should be. I hope you got somewhere through it. If not, then it should all be written, include the entire session is written in a style of our tutorials online, so you should be able to go through and do that in your own time. And as I said, in the second lab, the one over the way, then I'll be there all afternoon or not all afternoon, there for like an hour and a half, and we can go through it then, or catch me any time throughout the week. So in conclusion then, what have you learnt today? Well, first of all, we started looking at visualizing Git repos. How do we understand this repo that we've been given? What does the tree look like? What are the different commit messages look like? As part of that, we looked a little bit about the working directory, the index, and the tree. We then went on to do merging, rebasing, and cherry picking, all the different ways that you can work with branches and join stuff together and pull bits and pieces around to suit your will. Then in the lab, which you may or may not have got to, you did some stuff with the programmatic time machine with filter branch, which is incredibly powerful, because if you haven't accidentally committed a load of secrets into a Git repo and have tried to get rid of them before, this is the way to do it. It rewrites history, which, as I said before, has a massive great warning on it, but it's amazing what you can do using the filter branch. Then you'll have looked at the different phases of undo, the reset, revert, the reflog, and all the different cases when you should use them and all the different ways in which you can use them. Stuff that we didn't cover today, but there is plenty of stuff out there to cover it. Git hooks. These are like little scripts that run as part of the Git lifecycle. After a commit, before a commit, on a push, on a pull, on a merge. All of these are little scripts that you can write and put in a repo that do all kinds of little different things. A lot of this is kind of the way that things like notifications on GitHub work, and you can use it for all kinds of things. We used to use it to match up Jira messages with the commit messages and that kind of thing. You didn't look at submodules and subtrees. They're the ways that you can, I've got one Git repo and I want to refer to another one inside it. You can do that with submodules or subtrees. They're quite complicated, in some senses overly complicated, but there are two different ways, and there's a lot of info out there about them. Bisect and blame. Bisect is really cool. Let's do blame first. I don't know why I put them in that order. Blame is the ability to find a particular line in a source file and see who was the last person who changed it and when did they change it as part of which commit on a line-by-line basis. Bisect is, I know that this thing used to work, but it doesn't work anymore. I've got like a test suite that now fails, but I know that 3 weeks ago it worked, but I don't know what I changed to break it. Bisect is the ability that Git provides you with being able to basically do a binary search of your commits, where at each stage you stop and run the test suite. And if it fails, then it searches in one direction. If it passes, it searches in the other direction. And finally, working with remotes is incredibly powerful as well. But there's a huge amount of info on this on GitHub and the such like. And I probably have a feeling that that's the kind of stuff that you do day in, day out. Where to go from here then? Probably my favorite example is on the Atlassian website. There's a Git thing in there with some fantastic tutorials. A lot of those are based on, that are kind of advanced tutorials for Git. GitHub has some more GitHub-focused things, but they still do a Git tutorial. And then the kind of the oracle, I suppose, is the open source Git SCM book, which is that really easy to remember URL. I want my real name on the Twitters, so do feel free to send me abuse. And just before you leave, please do take one of these cards. So if you haven't done it already, then get one out. Get a pen. The session is Mastering Git. The speaker is me. I'm Sam. And then there are 4 lines, and you need to pen. And then you just go down, and you put a circle around number 5 on each of those. What did you like best about this session? I'll leave it to you. You can sort that out. So thank you very much. If you have any questions, do feel free to ask me now. If not, then after lunch, over the way in Banneker or whatever it's called. Thank you ever so much for your time.